If I do that, that's what gives me that. And then if I do this. Anyway, real shorthand. That'll work better. Let's see, we want it to be, let me do it up. Here's what I'm looking for. UDV. Not UDU, UDV. And I got the proof on the notes if you don't believe me. It'll be U times V minus the integral of the opposite of that, V du. So half the answer will already be there for you because you got U and V. You don't have to take the integral of that, but then you have to take the integral of U. Okay, I gotta figure out which part of this I want to be U and which part of this I want to be dV. So I'm gonna let you, I need to find U equals something dV. Let U equal e to the x.
Yeah.
Okay, we'll try that. Sometimes we let U and dV be something that makes it more complicated, and then I go just scratch it. I go back. So we'll try this. And so that means if U is that, dV is sine x dx. So there's my U. There's my dV. So I'm going to use that. So if I took the derivative of e to the x, I'm just going to get e to the x, right? And v, if that's dv, is this minus cosine? Now let's see if that works. Okay, so this integral, that integral, will be u times v, which is e to the x, negative cosine x, so negative x cosine minus the integral. That part's done, because I know what u and v are. I just have to take the integral of the opposite of this, which is going to be v du. Oh, I forgot to put dx. I could change it. I could bring that negative out, right? I mean, I know I at least see that. And this is done. I don't have to do anything with that. I'll bring the plus. Negative out, make it plus. 1, 2. Put the e to the x up front. Pull the negative out. Cosine x. dx. Yeah, looks like I'm back where I started.
Could you split?
No, that only works for addition or subtraction.
So you could do anything.
You wanna do it again?
Yeah.
We could do it again. Okay. Now this time, let's see, that was the first. So this one, this part we already got, right? I don't have to mess up that part. Maybe I have to find, well, I don't know what you want to do. So this one's gonna give me another. You wanna try it again? With x being e to the x? Or u being e to the x, I'm sorry. U being e to the x. Du being e to the x dx. And so that would be u, and this would be my dv cosine x. Right. And that would mean v would be sine x, right? So that means, this part, I have to do the same thing. That's gonna be uv, e to the x, sine x. Minus the integral opposite of that, which is gonna be what? Sine x, e to the x dx. And I just, sine x, e to the x dx, I'll say e to the x, sine x dx. I don't wanna make the e to the x look like it's part of the sine.
And you just do it.
I guess we don't know. You don't really need to put brackets around that much.
We did do it right.
Wait a minute,
Do we just do it again then?
do it again?
Yeah.
I have a feeling if we do it again, we're
It's just gonna continue to loop because it's a sine, cosine, negative sine, negative cosine.
Oh, yeah. Oh, yeah.
Can we put like
Integral,
three dots?
like what I do is just go the whole integral, for example, I, like,
Can we use
I just say I equals that.
No, it's not a limit.
I don't know how to spell. Can I go answer?
You probably could, but watch this, guys. What am I trying to take the integral of? E to the x sine of x dx? Watch this. Watch this. I'm gonna add this over because they're like terms. Sine 2x. Sine of x dx. So I'm gonna move that over here, give me that, and that's gonna equal, if you want to, you could. Just factor, you don't have to do that.
That's what I was telling you.
Is that what you were saying?
Yeah, like instead of putting the whole integral, I just call it like I, and it's just like it's simpler.
Like it's a variable.
Mhm.
Yeah, like it's a variable. Hey, divide by 2. There's the integral of e to the x sine x dx. If you see the same thing over there as what you're trying to find, well, bring it over to the other side. Those are like terms. I kind of like going in a loop, because if I go in a loop, then I get the same thing. And Christian was saying kind of treat it like a variable. X is like this thing plus this thing minus x. Or he said I think,
I because it's integral.
yeah. Integral. I for integral. Oh, so algebra says I can combine like terms. And there's my answer. I kinda
What
like
if
that.
it was plus?
And you had to end up, and then it would go away. It wouldn't work, but with integration by parts, it's always minus the integral. So you've got always minus the integral. But it, you know, if for some reason it canceled each other out, it wouldn't work. I thought that was cool. Because we forget what we're looking for, because we're calling it UDV. We completely forget that this is what I'm looking for. Oh. Put it in there, I see the same thing over there, I got two like terms. Okay, so this is called integration by parts, because we're doing U part, V part, which is representing two functions, like f of g times, f of x times g of x, when I was taking the derivative. So this is how I work backwards from the product. And then we got one more. And this is going to be a definite integral. Looks like it's getting brighter out there. Hey, hint, hint, we're gonna use integration by parts here. So I need some parts. I need a U. I think we're kind of stuck on what I get to choose.
Just like U inverse thing.
I think that's my choice. I don't have a choice, right? I'm kind of stuck with this. And that means that would be that. I mean, I can't make U dx. But then working backwards, V, well, underline. That'll make that U. And that dV. So working backwards, this would be, V would be just X. And what would D be?
1 divided by square, no, x squared plus 1.
How do you remember that? Wait, is it 1X in the term? Yeah. Oh, dx. Got my dx. But you could put it in the top. Yeah. I don't know how you remember. That's good. Well, let's see if this works. I don't know. So, let's see, the integral. Well, okay. Integral from 0 to 1. How do I write this? Oh, it's a UDV. Is going to equal U times V minus the integral V du. Okay, there's what I wanted to do. Well, I got this one. U is inverse tangent x and V is x. I'm going to put the x up front so it doesn't get lost back here. Inverse tangent x. I don't have to take the integral of that, but it is a definite integral, so I'm going to have to take that from 0 to 1. Because that is part of the integral. I just don't have to integrate it. And then I'm going to have definite integral. pulled a LeBron James.
Forgot.
Forgot the plus.
Oh,
I think I forgot to put plus C.
it's embarrassing.
That is embarrassing. Oh my God, don't tell the rest of the school. That just hit me.
They publicized the problem.
What if I'd already turned in my paper before? Okay, anyway, we don't have to do that here. That's what made me catch it. It was like, we don't have to do, oh, I didn't do that on this one. Okay, so, and then I've got the integral from, in terms of u. Minus the integral in terms of u. So, v du.
You have to make, you have to put the integral and the integral 0 to 1.
Yeah, that's gonna be, I'm gonna have to change that, right? So this would be v and du would be x over x squared plus 1 dx. And then I'm gonna have to change my intervals of integration. How am I gonna do that? What am I gonna plug it into? I was going from 0 to 1 over here, but now I brought in a different variable, and I'm doing it in terms of x. So I need to change the 0 and the 1.
You can say that x squared plus 1 is f of x, and top is f prime of x. So you need to add that to the
Oh,
top
you're
and then
doing
divide.
that. Right.
Mm-hmm.
Oh, actually, oh my God, it's over here. Oh, it's over. Hey, this one was in terms of u. When it was in terms of u, I was going from 0 to 1. In terms of u. Right. Now I want it in terms of x. What am I gonna plug it into?
D.
Let me see what I'm doing here. Am I doing it the same way you want to do it? Check my notes. Yeah, I actually did it your way. Over here. I did it your way. Yeah, we got that, okay. Oh, I would have to do, sorry. That's what I've got to do another substitution there. Do I? Do another substitution. What am I
Couldn't you rewrite x divided by x squared plus 1 as x times x squared plus 1 to the negative 1?
Wait a minute. X squared plus 1 times x to the negative 1
No, x times,
this to the negative 1.
yeah,
Yeah, you could.
and then you'd have like two distinct, and then you'd be able to do the u and the dv again. That work?
Yeah, that probably would work. But I see something here. I don't have to do integration by parts again, because I see this and I see this. So if I let u be x squared plus 1, I guess we're going down.
This is pretty fast.
Then du is gonna be 2x dx.
Explain.
Hey, I see the x dx
So divide by 2.
and divide by 2. Or if you wanna do 1/2, whatever, x dx. Hey, that will allow me to rewrite, well, yeah, let's go ahead and rewrite this. As the integral of, 1 over u, right? 1 over u. X dx is 1/2 du, which I can pull out the 1/2. 1 over u du. Now I do have to change my intervals, and, yeah, my intervals. So, da-da-da-da-da, when x is 0, I guess I got 1, right? And when it's 1, it looks like I got 2, right? Now that's gonna be pretty easy. What I haven't done yet is plug this in. The top 1 times inverse tangent of 1 minus 0 to, oh, doesn't matter, inverse tangent of 0. That's just gonna be 0. Does anybody know what the inverse tangent of 1 is? Tangent of something causes tangent to be 1. What angle causes tangent to be 1?
40.
My favorite angle. Sine and cosine are the same thing. And that's pi over 4. That's what C is. Right, because 0 times anything is that. Then I got that. Pi over 4. And I don't need that. 1/2. Hey, what's the integral of 1 over u?
LA.
Natural. So that's gonna be pi over 4.
Can you repeat what you did from 1 to 2?
Huh? Because when I changed the x to u over here, I went ahead and changed my intervals of integration from this to that. And that's when I changed it from x to u. So if I'm doing it in terms of u now, it's not going from 0 to 1, it's going from 1, when x is 0, it's gonna go from 1, when x is 2, when x is 1 to 2. So this will allow me to do, I don't have to, I mean, does anybody really wanna substitute natural log of x squared plus 1 in here? Try to figure that one out. So I got minus 1/2. Let's see, natural log 2. Minus natural log 1. That's gonna be pi over 4. Does anybody know what natural log of 1 is? E to what power is 1?
0.
Yeah.
E to 1, oh, that's just 0. Just, we got rid of that 0. So it's basically minus 1/2 LA2. Oh, wait. Now, you guys were shouting out different ways of, and yeah, those ways will probably work.